Today we're going to strip down and service a Gilbert kitchen clock from the early 1900s. First thing we do is remove the pendulum from the movement. And put it to one side. Now we can lie the clock down on its back so we can start work on it. Now we'll remove the hands. We'll remove the taper fin first to release the hands, then the little brass remove the hand, minute hand. Now we'll remove the hour hand. That's got him. Right, put him aside. Now we can start to take the movement out. We'll remove the gong. It'll make it easier when we take the movement out. First screw. Second one. A little bit not quite loose enough. Now we can remove the gong assembly. And put it to one side. Using a small screwdriver, we'll now remove the dial. The other screw on the other side. One. Second screw coming out. Now we can see and access the movement. Using a larger screwdriver this time, we'll undo the large screws that hold the movement into the case. One up the back, up here. Helps if you've got the right angle. Almost loose. We can now remove the movement. Being a bit careful because the springs have wound down. So actually what we'll do before we take it out, we'll wind those springs up a bit. Winding the springs up a bit will make it easier for us to remove the movement out of the case. Okay, the movement comes out nice and easily. Grab those couple of screws. I'll remove the case. And there we have the movement. The front and the back. Alright, let's take it to pieces now. It's a good idea if you haven't done a lot of work on mechanical clocks, when you're taking them to pieces, to separate the going side from the strike side and keep your parts separate. It'll be a lot easier to put it back together again. First we'll take out the suspension spring. Being careful not to bend it. Very gently. Almost there. Right. Now we'll remove the crutch, take that off, put it aside. Now we can access the fifth nut that holds the plates together. We'll loosen that off. We'll tighten up the springs, wind them right up. So we can put a mainspring clamp on them, each one of them, to hold them tight while we take them out and remove them from the movement. Right, let's see. I'll place a set of tweezers into the escape wheel, which will hold it, while we check and see if we wound sufficiently to be able to put a spring clamp on. Not quite. A bit of a... still not quite there. This has to be him. Alright, we're now on there. So remove the key using a let down tool. We'll pull the click. Pull the click away from the ratchet wheel, let it down slowly while we check to see if the spring will hold in place. A little bit more yet. The clamp will hold. There we go. Now remove the tweezers, the escape wheel. There's now no power getting through to the escape wheel. I'll put a mainspring clamp on the other spring off camera to save us some time. Now that the springs are both being contained, we can remove the nuts holding the two plates together. One and the fifth one. Now very carefully lift up the front plate by pressing on the last little bit of tension out of the springs, and then lift the plate with taking the escape wheel out. We'll put that in the time side container for our parts. Now, next piece, motion works. Comes off the top. Next wheel. Third wheel. Second wheel. First wheel. And we'll take the strike lever out. You'll have to bend up the little spring that holds it in place. There we go, we can now remove it. The spring that powers the time train. There. Now, another lever, a little spring on it. That one. And one, we'll pop them in there. The count lever. Now the vane, the governor. Turn it around so we can see it better. The first wheel, if we can get it out. And then remove the time train spring. There we have it, it's all stripped down. That's our parts, all from the strike side in one container. These are the parts, the wheels and the motion works from the time side in a separate container. So before we can put the parts into the ultrasonic to clean them, we'll have to remove the springs from the clamps, clean them, and that's what we'll do next. First we'll remove the mainspring clamp from the spring, then we'll clean the spring. First thing to do, Tighten the winding arbor. Into the spring winder. Place this hook in the back. Then tighten down the spring winder. That's got it. That's all tight. Now wind the spring a little bit tighter so that we can remove the clamp, like so. Reverse the motion of the winder and slowly let the spring down. Alright. Now remove the spring from the spring winder. Now we'll clean the spring. Now remove the spring from the winding arbor. Now put a piece of plain rod into the spring winder. Put the spring on that. Pop the clamp on. Now we'll put a little bit of blue Kero on a light abrasive pad. And then we'll move that up and down the full length of the spring to remove any grime, gunked up oil or anything else that's on the spring. Full length up and back. Alright. Now, using a piece of dry cloth, wipe the Kero off the spring. Right up to the top. Then wiping it down again to the full length. Turning it over, keeping it clean side there. Now we'll let that sit for a minute while we get another piece of clean cloth and wipe it down again. Okay, next piece of clean cloth. We'll repeat the drying of the spring and cleaning all the Kero, that's looking cleaner, all the Kero off. And then back again full length of the spring. The rag's looking pretty clean. We're ready now to lubricate the spring. Now, we use PTFE grease to grease springs, mainsprings, because oil will be pushed out very quickly once the spring is tensioned. Right, unwind the spring. It's now nice and dry because we've cleaned it. And then squeeze some grease, a little bit of grease on your finger, touch it with your thumb to spread it out, thumb on the top, finger on the bottom of the spring, and then slowly drag your finger and thumb along the spring as such. You run out of grease, a little bit more, squeeze it between your thumb and finger, and repeat, running down the full length of the spring. One more. All right. And then we'll go back and check the grease is evenly distributed. Wind the spring back, thumb and finger again, pull it down, smoothing the grease as you go. Okay. Almost done. Right down to the loop end. Right. Now, move the spring, which is now cleaned and greased. Place it in a bag. Preferably marked so you know which spring is which. This is the one from the going side. And put it aside. If you have any comments or questions, please leave them in the comments section below. I'll now clean the strike side and I'll respond to them. Spring, then we'll resume. Thanks for watching. To keep the parts separated so that you know which is the strike side and which is the going side, it's easy to use a little bit of wire and tie all the pieces together from the one side of the movement, like so. Give it one or two twists to hold it together. Put that aside. Then we'll do the going side. Same thing. Spread them onto the piece of wire, hold them all together. Escape wheel. Motion works. And that last wheel. Wind them together. Put it back in there. Now we'll get the basket from the ultrasonic. Bring it over. Put the plates in down the bottom. All the going parts in there. Strike parts without that lever go in there, and then the 5 nuts that hold the movement together. We'll put them in this little basket so we don't lose them in the bottom of the ultrasonic. Close it down, pop it in there, and then put the parts into the ultrasonic. Turn it on. Right, time's up. We'll take the parts out of the ultrasonic cleaner. These are our parts that have come out the ultrasonic cleaner. They've come up very well. You can see how well the wheels have come up. Nice and shiny. Alright, take them out of there. Those, and there the nuts. There. Right. Okay, let's put the wheels back into the movement so we can check the pivots and the bushes to see if we need to do any rebushing. First we'll put in the count wheel, then the first wheel, the cam wheel we'll put under there. It's driven by those teeth there. Then the third wheel. And then the fly or governor. Make sure it fits in. Okay, there we have it. Now we'll put the top plate on. We'll put a nut on one of these posts to hold the plates together while we're aligning the pinions. Right, now lift it up to eye height so you can see what we're doing. Now we set the pivots into the holes and pushed. That post in there. Bring the vane up and put that in there. That allows us to get the third wheel aligned. And the first wheel. Hold the plates together. Turn them, make sure that they're working. Now another couple of nuts on. Tighten them down a bit. So we can see one's alright. The pinions look like. Probably tight enough. Okay, we'll spin the wheel. They're all moving freely. Now, we now look at each pinion and we move the wheel left to right to see if there's any movement in it. That is probably about alright for an American clock. That would be no good in a French clock. You'd have to rebush that. They have much finer tolerances. Now the third wheel. That's alright. Check for end play to make sure they can move backwards and forwards. And I'll check this guy. Move him up and down. Check the other side. That one. Check the cam wheel. Nope, they're all right. Now we'll remove these nuts. Take those wheels out. Put them aside. Then we'll put in the going train wheels. Put a little bit. Take the third one out. Now top plate will come off gently. Take it off. Remove the wheels. One at a time. Put them down in the order we took them out to make it easier to remember to put them back in. Now we'll do the same for the other train. First up, we'll cut the wire that we used to hold them together in the ultrasonic cleaner, and take them out. We don't want that wheel for the moment. That's the motion works, we don't need that at the moment. Right, we'll put them in the order that we're going to put them in. That's the escape wheel. Now we'll do that. Right, let's put in the going train. Start off with the first wheel that has a spring around it. Put in the next wheel. To lift that up for a second. That in. One goes there. And we want that wheel going there. Put the top plate on. Put one nut on the post to hold it. Then we'll fit the pivots into the bushes. Now, that plate set there, that one in there. Right, now, pop him into there, goes into there, hold the plate together so they don't pop out again. This one, remembering not to press the plates tightly together or you'll bend a pivot. Then put a nut on this post down here. That'll hold the two plates loosely together while we're setting the wheels. Right, now what have we got? That's in, we'll align over the posts. Click, sounding better. Right, start putting the wheels in. First wheel is in. Second wheel and the third wheel. Give them a quick spin, make sure they turn, yes. Now tighten down that nut. We'll put one on the top up here. and one over there. No need to tighten them down tightly, by hand will do, because we're checking the pivots in the bushes. Okay, turn around. Okay, now let's have a look at the pivots. Little bit of movement in that one, not enough to worry about. That one's good. Third wheel. No, that's all right. Flip it over the other side. Move the wheel backwards and forwards. Those bushes look alright. Now we'll check for end play. Make sure we can move the wheel. Backwards and forwards. You'll see the lantern pinions moving there. Same on this wheel. Alright. No bushing to be done on this Gilbert. Now it's time to reassemble the movement. We'll start off by putting the springs back onto the winding arbors. This is the going train spring that we cleaned and lubricated in a previous video. We'll now tighten it up and put a mainspring clamp on to hold it in place. That's right. Now reverse the flow of the spring winder until the tension is held by the mainspring clamp. Now we can remove the going side spring. We'll now repeat the process for the strike side. Hook on the bottom, and wind up the strike side spring onto the arbor. Get it tight so we can put a mainspring clamp on it. Okay. Reverse the spring winder and slowly unwind so that the tension on the spring is taken by the mainspring clamp. There. Take it out of the spring winder. Another loop end spring is ready to be installed. A quick run down each side to remove any burrs from the filing. Now, right, that looks better. I'll take that out. Now we have to do the worn wheel lever. I'm going to turn that around a little bit and make it a bit more accessible for me. And we'll take slight bumps out. And smooth that off. Now I'll buff it a couple of times with a 1200 grit stick to get it smooth. Right. Now for the cam wheel lever. That also needs to be smooth, it's flattened off. Light filing, we don't want to take too much off, you just want to smooth it off again. Once again we'll run over that with a 1200 grit stick. Final polish and smooth. Yeah, that looks pretty good. Right. We're ready to put the movement back together again now. Right, let's put the springs in first. Strike side spring. Goes here. There, there. Now the going side spring goes on there. And got him, slides in there, a little bit over, down. Right, now the motion works. Goes there. That wheel goes there. Go under there. That's got it. Now, that lever goes there. The strike lever and the warning lever and the cam lever go in there, under there. Right. We'll put the hammer on. It's the hammer. Now we'll put the top plate on with the escapement wheel. Sit on top there. And then slowly that one and that one. Then drop it down to the pinhole down there. Right. That's everything in place at the moment. That's everything in place at the moment. Now we have to get it all tied down. We'll align the hammer so we can put a nut with 1 or 2 threads tightened just to hold the base plate, just to hold the top of that plate in place so it doesn't move. First we'll set the hammer starting from the bottom of the movement. Being careful not to press too hard on the plates or you'll bend a pinion. Looks better. Okay, they're both in. Now, one in place. Second wheel. Now we better start getting the levers into place. Well, first up we'll do the escape wheel. Got him. There and there. That and that. Come on. Alright. check. That one. Yeah. We got that one. That one. That's got to come into there. That's right. And that's in place. That one's in place. That one. Fly. That one. Right, let's put a nut on one of those posts. Hold it so we can have a look and see what we've got. Now, time train's moving smoothly. There we've got we'll bend those levers later. We just want to make sure that all the wheels are working. Now what we've got to do, we have to set. There are 3 things you have to set on an American movement. I'll loosen that off a little bit so we can spin that round. I've removed the fly and the warning wheel so I can get the cam wheel to align properly. First we'll put these pivots back into place again, and we'll get that lever, warning wheel back in again. You'll see we've got the count lever deep in one of the cut-off slots. There. We've got the cam lever in one of the slots in the cam. We're now going to put in the warning wheel with this pin here, just in front of that lever there. Turn that round over the top of that, and then that. Can go to there. Right, now we can put that back together again. Now that those 3 have lined up, I thought the hammer had moved out. Put the hammer back in. Got him. Tighten those nuts down a tiny bit to hold it. And start putting the pivots back in again. Cam wheel. Make sure that the lever is still in the cam. Right. That one. The scope wheel. That's right. That one's done. One's done. Now the levers. Count lever first. and the other one. We're almost there now, getting the last couple in. And the fly. Right, we'll tighten a couple of nuts down, hold it in place. Give the going side a spin. It's all working. Now there's three things you must have aligned on an American clock if you want it to work properly. Number one is the count lever in one of the deep grooves in the count wheel. You hold that there. Then you go over to the cam wheel, which we can see there. That's the cam wheel. That one there. That lever must fall in to that cam on the cam wheel. And number three, the warning pin there on the warning wheel must just touch on this side, not the other side, this side of that lever there. Right, I'll put the movement on a test stand so we can check and make sure the count wheel's working properly. Because we haven't got any pressure in the spring, and spin the wheel once and it stops. Lift it, spin it again. 1, 2, 3, 4, 5, 6 o'clock, and it stops. Lift the wheel. A half hour, 6:30. Right, that's good. We'll put the verge and crutch on now. Okay, we'll lock it down. Now we'll take the mainspring clamp off and test the count wheel under the pressure of the spring. It's a little bit tight. There. Almost off. Right. Now we'll lift the count lever, see what happens. 2, 3, 4, 5, 6, 7, 8, 9. 9 o'clock. Click it for the half hour. Half an hour. Test it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Now we'll attach the spring for the hammer lever and also for the count wheel lever. Hook it over that pillar. Tighten it down a little bit. See what we got. Half an hour. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Excellent. We're going to put it on a test stand and connect up a phone app to check and see how accurate the time is. Spec on a mechanical clock is 5 to 7 minutes per week, so we need to go way better than that. First we'll attach a beat amplifier, which will make it easier for us to hear when getting the clock in beat. Now, to get the clock in beat, we'll lift it from one side first. That's getting out of beat that way. Then from this side. Well, that's not too bad. Now I'll get the phone app going. Clock Master. That's the one there. I'm going to calibrate first. Hit the calibration button. We're looking at the beats per minute. We'll adjust the sensitivity up to 10. Then we'll slowly slide it down to the beats per minute smooth out. You'll see the delta on this side. The closer we get to 0.01, it means that the clock is in beat. Done. We'll set regulation, start it. There's some figures, right. We'll take 10,000 samples, which is just under an hour, and then we'll see what the error is per day, and then we can adjust the length of the pendulum accordingly. We'll come back in an hour and see what that reads. Okay, there's our reading. Minute 45 per day, so that's outside spec. Recalibrate and we'll run it again. Back again a couple of hours later. I made a few minor adjustments and that's what we've come up with now.